Okay, so we're going to go through this quite detailed example on 13.4. I would suggest that you go through it but then pause it as we go through. So here we've got two cells, P and Q, and a resistance R in a circuit. Resistance R has 4 ohms and they're connected in parallel to each other. Oh, 1 second, hang on, my daughter's here. Okay, sorry, she's gone. Right, so you've got cell P here as well. That has an EMF of 2 volts and an internal resistance of 1.5 ohms. And we have cell Q, which has an EMF of 1.5 volts and an internal resistance of 2 ohms. And it says calculate the current in each cell. And you might think, well, that looks fairly easy. Okay, it ends up being a little bit more complicated because there's basically 2 unknowns here because we don't know the current here and we don't know the total current. So the current in R, because of Kirchhoff's first law, will be a current here through P and a current through Q added together. So the question's called this X and Y. So I've said here, well, the current through R is going to be the current through X and the current in Y added together. Okay. So now we're going to look at the loop that contains P and R. So just this loop. Ignore Q for now. So if we look at just that loop, the sum of the EMFs in both the loops will be 2 because you've only got this one, P. The potential difference across P here, so how many lost volts you're going to have, will be the current, which is IX, times the resistance of this, which is 1.5 ohms, so it's internal resistance. Okay, because V equals IR. The potential difference across here is going to be its current, which is I've called IR from here, times its resistance, which is 4. So the current through it times that, and we know that this current is made up of these 2. So I've substituted that in there. So that's my equation. We know that due to his second law, the sum of the potential difference around the loop will add up to the EMF. So the EMF of this will be the potential difference lost here plus the potential difference here. So it's like 2 steps on the that diagram I was showing you before. And that will add up to 2 volts. So the lift up is 2 volts and you've got a step here and then another step here. Okay. So the sum of the PDs around the loop will be the PD lost in the internal resistor, which is this expression, plus the potential difference drop across the big R, which is this expression. Just going to expand this bracket. So now you've got 4IX plus 1.5IX is 5.5IX. And then you've got 4IY there. And that'll add up to the EMF there. So I've got this expression here. What we're going to do now is do exactly the same thing for this loop here. So the loop containing Q and R. So again, the sum of the EMFs in both loops will be equal to the EMF of this cell, which is 1.5 volts. It has an internal resistance of 2 ohms, so the potential difference drop across this resistor will be the current, which is Y, IY, times its resistance, which is 2 ohms. And the potential difference drop across R is going to be its current, okay, which is the X plus the Y times 4, the same as here. Again, I can make a new expression because the sum of the potential difference around this loop, okay, will be equal to the potential difference I've dropped here plus the potential difference here. So the potential difference of the internal resistor plus the potential difference across the external resistor. Add them together. I've got to expand out this bracket, so I've got 4IX, so that's fine. And then I've got 2IY here and a 4IY here, and add them together and you get 6. And that will equal the EMF 1.5. Alright, so 1.5. Right, so I've got myself 2 expressions. Those are those 2 expressions I've just made. Unfortunately, they both have 2 unknowns. So I need to get rid of one of them, one of the unknowns, to make find out what the other one is. Nicely, both of these fit in 12. So I'm going to try and make 12iy here. So I'm going to multiply expression 1 by 3. So this one by 3. So get here 3 times 5.5ix plus 4 times iy, and that will equal 2 times 3, because I'm multiplying everything by 3. So that's 16.5ix plus 12iy equals 6. So I've just expanded out this bracket and then done this sum here. To make this 12, I need to multiply number 2 by 2. So I'm going to multiply second equation by 2. So 2 times that expression and 2 times the EMF. So I get 8ix equals 12iy plus, which equals 3. Right, I'm going to subtract the two equations because then I will subtract 12iy from 12iy and I get 0iy. So it gets rid of the term. So 16.5ix minus 8ix is equal to 8.5ix, which is then equal to 6 minus 3, which is 3. And I can rearrange this to get a current of 0.35 amps. Okay, I can then sub this back into either one of these, and I will find iy. So I think I've subbed it into, oh, I don't know which one I subbed it into. You get a slightly different answer for both of them because I rounded this. If you don't round it, you still get a slightly different answer for both of them, but I think they round to the same number. So it's 0.015. Now, that gives you a total current of 0.37 amps. But that's all rounded to 2 sig fig. If you look in the book on page 225, they actually get a different answer. They get a negative answer, and they've tried to justify that by saying that one of the cells is in a different direction to that we assumed in the question. But I can't get that negative answer. I don't know how they've done it. If you go through this and you can figure out where I've gone wrong, so get a negative answer for this. They get the same answer as me, but negative. So if you can see if I've gone wrong somewhere and it should be a negative answer, please let me know and I'll change the slide and send a new video. Right, what I want you to do is do these questions, and then again in the next video I'll send the PowerPoint on how to do them, and you can upload a picture of you marking them. And if you have any problems whatsoever, please contact me. Okay, thank you, bye.